so this is on page 5 in your packet, and we had not done the mean problems yesterday, so here's the mean problems. Okay. What I actually want to do is teach you about this mean process by doing the example. So we're just going to kind of dive into this problem. I would like to change it 2 ways. I want you to split this in half because I want to do number 1 2 separate ways. I want to do it the way we would do this problem if it was a last semester problem. And then I want to tell you what about this semester makes it a little bit different, what is different about it, okay? The other thing is this problem doesn't have context, so I'm going to add some context to it just so that I can talk about it and say things easier. So let's pretend that this is a distribution where the average number of carbs in a cookie, let's say a cookie. Okay, so this is the grams, so 30 grams of carbs in a cookie. So don't you think we need to try this out and see if that really is the case and bring in lots of cookies, okay? Like our M&M lab. Okay. So our mean is 30 grams of carbs in a cookie. That's the average number of grams in carbs in a cookie with a standard deviation of 4. All right, so it says a sample of size n equals 64. So that is the new kind of stuff that has happened this semester. We have started talking about samples of size 64, where we would get, a sample of size 64, and we would be getting an X bar, and what is this? This X bar represents an average. And what do you think we're going to be talking about the average of? Good. So that represents the average grams of, carbs in a cookie. All right. So what I want to do first is do this problem like last semester, where all we would be looking for last semester is 1 cookie. All right? See, that's the difference. Last semester we were saying, what's the probability of finding a cookie that is greater than 31 grams of carbohydrates? So that's what it says. Find the probability that whatever it is we're looking for is more than 31. So last semester we would be saying what's the probability of a cookie greater than 31 grams. This semester we're saying what's the probability of getting a sample of 64 cookies that average, all those 64 average 31 grams or higher. What do you think is going to be more difficult? Finding a cookie at 31 grams or higher, or finding an average of 64 cookies at 31 grams or higher? Any ideas? What do you think? You think the average? You think a cookie? Okay, well, let's see. All right. So first, let's do this just like last semester, where we say the average for cookies is 30 grams. The standard deviation for cookies is 4 grams of carbs. Okay, what's next? The X value, the individual cookie I'm trying to find is at what place? 31, because it's going to be 31 or higher. You do use that number and you don't quabble about equal to or just purely greater than. Okay? So how do I find this z-score of that location? Okay, X minus the mean over the standard deviation. And that's 0.25. So my first question is a common mistake I get. Does that mean there's a 25% chance that you would find a cookie at 31 or greater? No, it does not. That is the z-score, not the probability. Z-score is representing what? The number of standard deviations above the mean. So I'm a fourth of a standard deviation above the mean. All right. So how do I get the probability? How do I get the proportion of observations? How do I get the percentage? I'm going to norm CDF, okay? So I'm going to norm CDF, and I want to go greater than, so that's going to be 0.25 to 99. That comes out to like 0.4013. So if I was to write a sentence, what have I just answered? 14.13% chance that a random cookie, and it is a random cookie, one cookie has more than 31 grams of carbs. All right, so is that anything new? You good? You feel comfortable with that? We've done that a lot. If you're not comfortable with that, then that's sad. And then I'm sorry, but I have not done my job, or you haven't done your job, or one or both. Okay, I'm not going to end up doing that problem there because I've decided to do this a little differently. What I want to do is I want to draw two separate pictures. So make yourself a little dotted line. I want to draw a normal curve where we are talking about a cookie. And that's the one we just did. So let's draw a normal curve with a mean of 30. And then we've got our 31 grams of carbs right there because that's a number line. And since these are single cookies, the data that is in this curve is a cookie, a cookie, a cookie. This thing is completely filled up with single cookies, and so I pick a cookie and I see what the proportion of, or I'm sorry, the number of grams in it is, and carbs, and so these are representing a single cookie. Okay, and then here is the answer that we just found, and that probability was 40.13%. Okay, good? Got that picture? Now let's move on to this new semester, which is about samples of cookies, not just single cookies. All right, that's the key. Samples of cookies, not just single cookies. And what is a distribution of samples called? A sampling distribution, okay? So a distribution of samples is a sampling distribution. Okay, very good. All right, so let's do this problem over here on the right, which is about samples of 64 cookies and the average of those 64 cookies, the average grams. Okay, so the mean for the sampling distribution, oh, look up here. The mean for a sampling distribution is what? The same as this mean of the main distribution, with all the individual cookies in it. Okay, so it's still going to be 30. All right, but looky here. The standard deviation of the distribution with all the samples in it, the sampling distribution, is something different. This is the difference in this semester when we talk about sampling distributions. Or now you just have to pay attention. Is this a sampling distribution or just like a single distribution? Okay, so if it's a sampling distribution, then your standard deviation will be the main standard deviation divided by the square root of your, what's that? Your sample size. So in this case, it will be 4, because that's what the original standard deviation is, divided by the square root of 64. So that's 4 over 8. So our standard deviation in this case is 5. So here it's 4, and here the standard deviation is 5. What is happening if your distribution has a smaller standard deviation? Tell me what's going on. More centered around the mean, closer to the mean, more clustered closely, more consistent. All right, very good. So let's draw that picture. Okay, you ready? Come down here, and I want to draw this picture taller and skinnier. Okay, I'm not able to draw it taller and skinnier very well, but do you see it's kind of squished in? It's a little taller and skinnier. Now it is still centered. It's still centered around 30. So it still has a center at 30. And then here's 31. Now, what's inside there? This is a sampling distribution. You know what's inside here? Samples of 64 cookies. So you randomly selected 64 cookies at a holiday, 64 cookies at a holiday party, and you took the average carbs of those 64 cookies. So inside here is not a plain cookie. It's not one cookie. What is it? Yes, it's an average of 64 cookies. Here's another sample of 64 cookies and the average of those 64. An average of 64 cookies, an average of 64 cookies, an average of 64 cookies. All right? So this is a sampling distribution because it's a collection of samples of 64 cookies and the average of those 64. Looky here. What do you have to say about this area compared to this area? It's a lot smaller. Well, let's see how much smaller. Let's see what this probability is right here. It's going to be less than 40%, so let's go see. How do I go see? X bar, which is the mean of the sample I'm looking for, is still at 31. So what do I need to do to find that area? Same thing, z-score over the new standard, smaller standard deviation is 2. And if I norm CDF, anybody know offhand what's 2 to 99? It's 2.5%. Very good. Okay, because we had that from before in the upper tail, that's 2.5 up here, and the lower is 2.5%. Okay, so this is 2.5%. So now answer this for me. What is easier to find? A cookie at 31 grams or more, or an average of 64 cookies at 31? A cookie is, did I say harder or easier? I don't really know. I don't know. A cookie is much easier. This is much harder to find. An average is harder to find. A single cookie is easier. Okay, so when you do a problem, pay attention to the difference between a single item or a sample of items. Okay, let's do one more problem together, and then you're going to do the homework. So here we go. I want you to turn over to the next page, number 6 on the next page. Oh, sorry, number 5 on the next page. We're still on your notes. It's page 6 in your packet. Problem number 5. Here we go. A lumberyard sells odd-size 1x10 boards, and the process which generates these boards is known to operate in such a manner that the lengths of the boards are normally distributed, with 22 feet as the average length of those boards, and with the standard deviation of 3 feet. In a random sample of 60 boards, what's the probability that the average length of 60 boards, an average of 60 boards, is less than 23 feet? Okay? So, if I was finding a board, what mean would I use? Finding a single board, 1x10 board, what mean would I use? 22. What standard deviation would I use? 3. But if I'm finding an average of 60 boards, what mean do I use? Still 22. What standard deviation do I use? The new one, which the standard deviation of the sampling distribution is going to be 3 divided by the square root of 60. See, it's the old standard deviation by the square root of n. Okay? All right. So I want you to do that problem. Go, and then we'll check it here shortly. I'll walk around and see how you do it. Okay, so real quickly, I walked around, and most of you guys already have this, so you did great. Your standard deviation multiplication was 0.3873. There's your z-score, and you want the area below a mean of 23. And that was 99.5% chance that the average length of the sample boards is less than 23 feet. You see how I just restated the question as the answer. And then I know I answered what they were asking. Okay, done. So again, what I want you to do for homework is in your packet, pages 7 to 12. Last night you only did the proportion problems, so tonight I want you to do the mean problems, and we are not going on to the day 2 work, so if one of y'all will let Kristen know if she's keeping up, because she usually does that, that we changed, okay? Ooh.
Yeah, it sucks.
Did you have that?